Good evening and welcome to NPTEL classes. I am here to solve chemistry class 12th NCERT problem 2.25 and problem 2.35. Both these problems are from second unit of your NCERT chemistry, that is solutions. Coming first to problem 2.25. We have six solutes of different nature. We have in solution six solutes of different nature. One is phenol, one is toluene, one is formic acid, one is ethylene glycol, one is chloroform, and one is pentanol. And interesting thing is solvent for these six solutes of different nature is same, that is water. This thing is interesting. Nature of solute is different but nature of solvent is same, that too water, which is polar in nature. Now we have to answer which among these six solutes is insoluble in water, which is partially soluble in water, and which is highly soluble in water. We need to identify solutes that are insoluble, that are partially soluble, that are highly soluble in water. So problem is based on concept of solubility, and solubility of solute in solvent depends first on nature of solute and solvent, and guiding rule is that like solute likes like solvent, like dissolves like. Polar solute will prefer polar solvent, non-polar solute will prefer non-polar solvent. In such situations, solubility will be greater, and if combination is such that one is non-polar, other is polar, solubility will be less. So what we need to do here we need to identify first nature of solute and nature of solvent. Nature of solvent I told is polar, because water is polar, its dielectric constant is high, its dipole moment is appreciable. So coming to nature of solutes, taking first solution of phenol in water. Composition of phenol is that it has got non-polar hydrocarbon part C6H5 benzene ring, which is non-polar in nature. But to this benzene ring, one hydrogen is substituted by OH group, hydroxyl group. Because we know hydroxide group is polar, OH group is polar. On this basis, presence of this OH group in phenol makes it polar. So interaction here is between polar solute and polar solvent. Therefore, phenol will be soluble in water. I will not first jump whether it is partially soluble or highly soluble. I will say it is soluble in water, because polar solute, polar solvent is in solution. Next is toluene. Visualize solution of toluene in water. Toluene is benzene ring C6H5, which is hydrocarbon, non-polar in nature, but to this benzene ring is attached CH3 group, that too is non-polar. So toluene in total is non-polar. In solution, solute is non-polar, solvent is polar. It will be insoluble. Toluene will be insoluble in nature, insoluble in water. Next, formic acid in water. We have to visualize now solution of formic acid in water. Composition of formic acid is HC double bond OH. It has two polar bonds, C double bond O and OH. Not only this, it is a potential electrolyte. In water furnishes H positive ion. Considering this information, formic acid is polar. Water is polar. Here again polar solute, polar solvent. Formic acid will also be soluble. It is also soluble in water. Again, I will not jump into whether it is partial soluble or highly soluble. Next, ethylene glycol in water. Ethylene glycol is CH2OH, CH2OH. It has two polar OH groups. On this basis, it is polar. Water is polar. So this solution has polar solute, polar solvent. Ethylene glycol will again be soluble in water. Soluble. Now coming to chloroform, solution of chloroform in water. Chloroform is non-polar in nature. Chloroform is non-polar in nature. CHCl3, it is non-polar in nature. Water is polar in nature. Solution has non-polar polar solute, polar solvent. It is insoluble. It is insoluble. Now moving to last solute, pentanol. Pentanol is, it has 5 carbon atoms. It has 5 saturated carbon atoms attached to corresponding number of hydrogen atoms, but terminal carbon atom has OH group, and because of presence of this OH group, it will be polar. Water is also polar. Solution has polar solute, polar solvent. It is also soluble. As far as first part of question, if we need to answer, we are able to answer. Which among following solutes are insoluble? Answer will be toluene. Answer will be toluene is insoluble and chloroform is insoluble. However, left is which solutes are partially soluble and which are highly soluble. Now we are in a fix. In next 4 cases we are in a fix. Phenol in water, polar polar. Formic acid in water, polar polar. Ethylene glycol in water, polar polar. Pentanol in water, polar polar. Here magnitude of interaction between polar solute and polar solvent will determine solubility. Since solvent is same, so it comes to magnitude of polarity of solute. Magnitude of polarity of solute will determine which is highly soluble, which is partially soluble. I will first compare phenol and formic acid. Phenol is also potential electrolyte. Formic acid is also potential electrolyte. In water both furnish H positive ion. Phenol will give phenoxide ion and H positive ion. Formic acid will give formate ion and H positive ion. But formic acid, extent of ionization of formic acid is greater than phenol. So formic acid is more potential electrolyte, more powerful electrolyte than phenol. On this basis, I will label them that phenol is polar to the magnitude of, is less polar to the magnitude of 1. Formic acid is more polar to the magnitude of 2. Because it is potential electrolyte but to the magnitude of 1. It is also potential electrolyte but to the magnitude of 2. Now I will compare ethylene glycol and pentanol. Ethylene glycol has 2 OH groups, pentanol has 1 OH group. Because pentanol has only 1 OH group, its polarity will be less to the magnitude of 1. Ethylene glycol has 2 H groups, its polarity will be more to the magnitude of 2. One that is more potential electrolyte will have more solubility in water than the one which is less stronger electrolyte, which has less potential as electrolyte. And electrolytes will be more polar than those which are not electrolytes but are polar in nature. On this basis, I will say phenol is partially soluble because it is less potential electrolyte than formic acid. Formic acid will be highly soluble. Ethylene glycol has 2 H groups more polar than pentanol, so it is highly soluble. Pentanol will be partially soluble. Now I am at the stage where I can answer my question that among these 6 solutes, considering solvent for them is same, among these 6 solutes, 2, that is toluene and chloroform, are insoluble. 2, that is ethylene glycol and pentanol, are partially soluble, and 2 left 2, that is among these 2 are insoluble, that is toluene and chloroform. 2 are partially soluble, that is phenol and pentanol, and 2 are highly soluble, that is formic acid and ethylene glycol. This is the solution to this problem. Now today I have got one more problem because it is also based on solubility. Let me read this problem. Henry law constant for solubility of methane gas in benzene at 298 Kelvin is 4.27 into 10 raised to the 5 mmHg. Calculate the solubility of methane in benzene at 298 Kelvin under 760 mmHg. On reading, I got to know that here solute is gas and solute is methane gas and solvent is liquid benzene. Pressure is given, pressure of methane gas above benzene is given 760 mmHg. Temperature is given 298 Kelvin and Henry law constant at this temperature is 4.27 into 10 raised to the 5 mmHg. Now I need to calculate solubility of methane gas in benzene at this temperature. Because I said that problem is based on solubility, but here solute is gas, solvent is liquid, and solubility of gas in liquid has direct dependence on pressure of gas, and exact quantitative relation was given by Henry, and Henry said that partial pressure of gas and solubility of gas has linear dependence. I mean, on increasing partial pressure of gas above the liquid, solubility of this gas in liquid will increase linearly. But most commonly applied form of Henry law is partial pressure of liquid above the partial pressure of gas above the liquid is directly proportional to its mole fraction in solution. Here mole fraction is used to express solubility of gas in liquid, and most commonly used equation of Henry law is partial pressure of gas above the liquid is equal to Henry constant K and mole fraction of this gas in liquid, which represents its solubility. This is the applied equation of Henry law, and this equation validates that partial pressure of gas above liquid and solubility of gas in liquid expressed in terms of mole fraction has direct dependence, has linear dependence. If mole fraction of gas in solution increases 2 times, partial pressure will also increase 2 times. Now look, in this problem, partial pressure of methane gas or pressure over the above the benzene, pressure above the benzene is given 760. Here pressure above the benzene, pressure above liquid benzene is given 760 mm Hg. Henry law constant is also given Kh. Its value depends on temperature and nature of gas, and for methane at this temperature at 298 Kelvin, its value is 4.27 into 10 to the power 5 mmHg. Mole fraction is unitless. Henry law constant will have same unit as that of pressure. Pressure unit of pressure is given in mmHg, unit of Henry constant is also given in mmHg. Now I need to calculate mole fraction of gas, methane gas in benzene at what temperature? At 298 Kelvin. P is given parameter, Kh is given parameter. I need to calculate mole fraction of methane gas in benzene that represents its solubility at 298 Kelvin. X will be equal to, applying this equation, X will be equal to P divided by Kh. Pressure is given 760 mm Hg. Henry law constant is also given 4.27 into 10 to the power 5 mmHg. Unit is same. Pressure is in mmHg. Kh Henry constant is in mmHg. It will get cancelled. Now I need to divide 760 by 4.27 into 10 to the power 5. Answer comes equal to 1.7 into 10 to the power minus 3. Mole fraction has no units. Now what is this? What is physical significance of this mole fraction here? It represents solubility of methane gas in benzene at 298 Kelvin. And is equal to 1.7 into 10 raised power minus 3, less than 1, because value of mole fraction of solute in solution is always less than 1. And how much is for methane gas in benzene? 1.7 into 10 raised power minus 3, very less solubility. Methane gas has very less solubility in benzene, considering power is 10 raised to power minus 3. Class 12 students, be blessed. This is what I have got for you today. In fact, today I came with 2 problems because both were based on solubility. One, to solve problem 2.25, I used the idea that solubility depends on nature of solute and solvent, and polar solutes prefer polar solvent, non-polar solute will prefer non-polar solvent. Based on this, I was able to solve problem 2.25, and wherein I found chloroform and toluene. are insoluble in water. Phenol and pentanol are sparingly soluble in water, but ethylene glycol and chloro and formic acid are highly soluble in water. And problem 2.35, to solve problem 2.35, idea was that partial pressure solubility of gas in liquid at particular temperature depends on partial pressure of this gas above the liquid. Here most commonly applied statement of Henry law is used, that solubility, that partial pressure of gas at particular temperature, partial pressure of gas above the liquid is directly dependent on its mole fraction in solution. Solubility proportionality constant is called a Henry constant, and this is the commonly applied Henry law equation, and it validates that partial pressure of gas and mole fraction of gas, partial pressure of gas above solution and mole fraction of gas in solution has linear dependence, not parabolic, not hyperbolic, not exponential. And here I identified that partial pressure of methane above benzene was given, mole fraction Henry constant was given. I needed to calculate mole fraction, which is equal to 1.7 into 10 raised to power minus 3, and its physical significance is that it represents solubility of methane gas in benzene at 298 Kelvin. See you day after tomorrow, as tomorrow is turn of class 11 students. Allah Hafiz.